Well, this is electron configures, if I can talk, it's early in the morning and I'm trying to make this video. Electron configurations, introduction to electron configurations. I'll just read the slide. Here we go. All right, after today, you'll be able to explain how the electrons are organized around the atom. You'll know what an energy level is. You'll know what shapes each sublevel have. And you'll start predicting how many electrons can be held in each energy level. Quantum mechanical model of electrons within an atom says that we cannot pinpoint where an electron is, but we can get the probability of where the electrons is. So we can't say the electron is going to be located right in this spot right there, but we can say most likely the electron is going to be located in a certain position. Electron configuration basically shows how electrons are distributed within an atom, where they're most likely to be found. So we started off with a model where we thought about electrons circulating the nucleus of the atom in set rings, and it looks something like this. We had our nucleus with the protons and neutrons, and then we had our electrons that looked like they were chained to strings and they can only go around in a certain level of this atom. But that's not the truth. You can't handle the truth. They're located in principal energy levels, which does look like our ring model. We can have N, which is our principal energy level, which can have numbers like 1, 2, 3, 4, 5, 6, 7, and 8. This describes the average distance of an electron from the nucleus of the atom. So N equals 1 is going to be a close distance, 2 would be a little farther, 3 would be farther yet, and 4 would be the farthest one we've got on this particular atom. The energy of the electron increases as you move further from the nucleus. So literally, this electron parked out farthest from the atom has more energy than the ones that are situated closer to the nucleus. There you go. N equals 1, energy level equals 1, energy level equals 2, energy level equals 3. Lowest energy level. Highest energy level. Within each energy level, electrons occupy sub-levels. So we've got energy levels and sub-levels. Let's take a look at these sub-levels. These corresponds to different areas an electron can be located in an atom. We're going to represent these by letters. These are S, P, D, F, and G, H, I, and so on. But you'll see you don't need to know anything really past S, P, D, and F, because we don't have so many elements that we would actually even use G, H, and I. So let's talk about the S sublevel. It's described as being round or spherical, like a circle, like a circle, like a circle. The P sublevel is described as being dumbbell shaped, or you could say it's figure 8 or infinity shaped. The D sublevel is clover shaped. You can kind of think two of these double bell shapes paired up together, or like a little 4-leaf clover that you'd find in your yard in the summertime. The F sublevel is really difficult to draw because now we're into 3-dimensional shape. So the best way to figure this one is kind of like two of these D sublevels, but they're kind of sandwiched together. So this is in the flat plane, this is actually in a plane that's coming towards you. So we've got two of these shapes put together. It's easier to show with balloons, which we'll be looking at in a little bit. So the types of sublevels, here's our energy, N for energy, 1, 2, 3, 4, 5. In energy level 1, we would have only one type of sublevel, and that'll be 1s. Energy level 2 has two sublevels, 2s and 2p. Energy level 3 has 3s, 3p, and 3d. Energy level 4 has 4s, 4p, 4d, and 4f, and finally 5 has energy level 5s, 5p, 5d, 5f, and 5G if we had enough atoms. Now, you can see a very set trend in this. In the lowest sublevel, we only have one. Then in our next highest energy level, we have 2s, 2p, and so on. We're adding on a different sublevel as we go up in energy level. Because if we're thinking about the shape of an atom, the area right outside of the nucleus is going to be rather small. As we travel farther and farther out, the diameter of our circle gets bigger, and so we can have more electrons within that diameter. Each sublevel is oriented differently in 3D space, and each orientation is called an atomic orbital. Atomic orbitals can hold only 2 electrons, so with all these suborbitals, each of the individual ones can only hold 2 electrons. So, in S sublevels, there's only one atomic orbital, and so it can hold only 2 electrons. And you saw that in Build an Atom. Whenever you dropped one of the electrons in, it went to the first ring, and it only would allow 2 electrons in that first ring. The P sublevel has 3 orbitals within it, and each of those can hold 2 electrons. That gives you 6 electrons in the full sublevel. D has 5 atomic orbitals. Each of them can hold 2 electrons, giving you 10 electrons in the entire suborbital. F has 7. Each of them hold 2, which gives you 14 total electrons within that sublevel. You can see that they go up 1, 3, 5, 7. And if we had a G level, that would have 9 suborbitals, and we would have 18 in that one. But we will never deal with a G electron configuration. Orbitals for a particular sublevel are similar in shape, but different in orientation and size. I'm going to give you a handout, not today, but tomorrow, that you'll see that, the different 3D shapes. So the number of electrons in each energy level is basically, in the S we have 2. In the second energy level we have S and P orbitals, giving us 2 plus 6, which equals 8. The third energy level is SPD, giving you 18 possible electrons in the third energy level. The fourth energy level has S, P, D, and F orbitals, 2 in each with different numbers of suborbitals, giving you a maximum total of 32 electrons for an atom in the fourth energy level. In general, you'll have more electrons in P than you do in S, more in D than in P, more than F than in D. Electrons prefer to occupy the orbital that requires the least amount of energy, so we're always going to fill these orbitals from the inside, working our way out. We're never going to start from the outside in, because remember, lowest level for the electrons is where they're going to want to go. Okay, that's the end of note 1. This is probably a little bit confusing. I'm going to do a demonstration with some balloons to help you picture these orbital shapes a little bit. We're going to talk about how electrons like to occupy it, and you do not need to memorize all this stuff. We've got one small little piece of information you'll need to memorize, and you can actually get all this stuff right off your handy-dandy periodic table. All right, we'll do some more in a few minutes.